Welcome to the Southampton Education School Research Seminar Series. I am Achla Gupta. I'm a lecturer and program coordinator of our seminar series. Our events are open to all. We aim to facilitate meaningful conversations and contribute to advancement in the field of education. Thank you so much for your interest in this event. I hope you enjoy it. Please feel free to visit our website for details about our upcoming events.
When Atina invited me to give this talk, I thought, what can I talk about? As you've seen from the kind introduction, I have really gone full circle. I started off in a school of mathematics. I ended up in a school of mathematics via a couple of school of educations. So I thought maybe I need to talk about something which is a little bit more educational and a bit more theoretical, I want to say, rather than talking about kind of technical mathematical things. So this is why I want to talk about this work, which I carried out with Pietro Di Martino at the University of Pisa and Francesca Gregorio. And I want to investigate what is the role of the context in a lot of the studies that we do. So I've done it in this study formally. I've done it in other studies that I carried out. Occasionally I do interventions in assessment of mathematics. And I wonder, what is the role of the context? What is the role of why I'm doing this intervention in the UK? What if I did it somewhere else? This is not about assessment. This is about transition. So in this talk, I want to talk a little bit about the literature on the transition from schooling to university mathematics. I want to introduce the theoretical frameworks we used for this study, describe the methods, and present some findings. So pretty straightforward so far outline of a talk. So what is the background? Why do we worry about the transition into university mathematics? So of course I worry because I'm passionate about mathematics and I want my students to learn. But there is a lot more to this. So mathematics has become valuable on the workplace. The last data I looked at, which was data from 2022, I think, showed that mathematics graduates are amongst the most employable graduates out of university. They're really up there with the medics. So being able to gain a degree in mathematics is something that is really valuable for the student, not only because the subject is beautiful, but also because it opens a lot of doors in the UK. So the other thing that we reflected about is that the education system are widely different for fundings, from aims, from structures, from courses that are offered, from the way in which students join courses. When I first came in the UK, I just finished my first degree in Rome, and I was really surprised. Everything was different. I did not recognize what I saw as a university course. And so we wondered, is this an impact on the students' experiences and how students experience this transition? And we know from the literature, for those who know the literature, that there are a lot of studies that concern difficulties with mathematical formalism, with proof, with mathematical understanding of abstract objects. But this is not the whole story of the transition. Mathematics has some characteristics that are only kind of this discipline, but they don't necessarily relate to cognitive understanding of the topic. So these are the three, if you like, reflections that drove the research we put together. So the first thing that we did, and when I say we, I mean myself and my collaborators, conducted a systematic review of the literature of the papers that talked about the transition. So for us, and this will be clear in a moment, papers on transitions means paper that contrasts the before and after the coming into universities. And we started off from these seminal papers in 2008. Those who know is fine, those who don't know is the same. It's not really important. But we reviewed the literature and we found some interesting stuff. I will present here only the results from the peer-reviewed journal papers we found. We also looked at conference proceedings, but the talk is not long enough. So this is a table. It's only to say that there are some striking things that we see. Most of the research on transitions comes out of Europe. And there are groups which we know are very, very active. There is a German group, as you can see, that is very active into researching transitions from a quantitative viewpoint. And they publish fantastic research. There is preciously little research coming from other parts of Europe, from other parts of the world. Now, of course, this reflects a little bit the way in which mathematics education is kind of distributed across the world, but makes me think whether the research that I carried out within Europe, and already within Europe, the UK context is quite different, say, from the Italian context or the Greek context. What can I take from this research and think that could also be applied to students who are transitioning into university mathematics, say, in the Far East? And so this is what we really tried to do. The other thing that we observed, which is quite interesting, there are slightly more qualitative paper, but the distribution of methods is quite even, which is also an interesting thing. So this was the outcome of our review. So in short, in 2016, Godet had highlighted these perspectives on the transition. She talked about an epistemological perspective. So students arrived to university not having, I want to say, a deep understanding of how knowledge in mathematics is constructed. This is what this means. We have spoken about cognitive difficulties, and this has been researched very much. There is some research that talks about sociocultural difficulties, so changes to the pedagogical culture of mathematics with respect to the mathematics at school, impacts from the shift in background, and there is some research that has used Baudrillard framework to look at this transition. What has not really been looked at very much is the affective perspective of this transition. And only very recently, Di Martino and Gregorio and Geisler and Rolka have done some study that look at the role of affect in this transition. So what we wanted to do in this study was to have a holistic view. So not just worrying and say, oh my God, the proofs are so difficult, students cannot do them. We wanted to really have something all a bit of an encompassing review. The literature review was telling us that the cognitive and the sociocultural perspective have been investigated to an extent, but the affective perspective and the epistemological perspective are not. So it's like if there is a little bit of a hole there. So in summary, we are interested in the tertiary transition because we know that at the beginning of this transition, there is a crisis. I mean, countries that have different systems talk about an incredible dropout between the first and the second year. This is the interest from the German team, for example. In the UK, things work a little bit different. We found that two factors had been investigated and two factors not so much. And that this kind of investigation concentrates in Europe. So around the water cooler of an international conference in 2018, we got together and we thought, what about if we repeated the same study in 3 different countries? And this is exactly what we did. Before talking about the study, I want to conceptualize the transition into university mathematics as a rite of passage. So this is not entirely new. Already Tinto in 1975 talked about the transition into university as a rite of passage. But in 2008, Clark and Lorick asked themselves, what is then the score for mathematics? So if I can conceptualize this transition as a rite of passage, what are the features that are typical of mathematics students transition into university? So rite of passage is a well-established concept in anthropology. And I wrote in my paper, this is usually associated with childbirth, and my reviewers say, what do you mean with childbirth? And obviously I meant for the woman, not for the child, but you know. But anyway, and it's been used to investigate events like this. So what is a rite of passage? Or how do I conceptualize a rite of passage into university? So the rite of passage talks about stages. So the student, the human, the person is in the first stage, but has their community and their practices, and then they separate themselves from the first stage and arrive to somewhere else where they're not familiar with the practices and the community and what is required to be accepted in this stage. This stage where the person has left stage 1, but is not yet a stage 2, we call a liminal stage. So it's a stage of confusion and crisis, if you like. Then to this, there is consequent, if things go the way we want, an incorporation stage where the person learns about the practices and rules of the new community, and they get to the final state. How do I kind of read this in terms of mathematics? So the first state is the student who is studying mathematics at school. Typically, when students join mathematics degrees in the UK, they are the high achievers of the A levels. So this was the studies. I mean, there's been a paper recently in the Teaching Mathematics and its Application, which is called the Pipeline paper, which tracks the students from GCSE into university. And it's quite clear that unlike any other disciplines, students in the UK, only students that are predicted A and A stars think about going into mathematics. This is not true for any other of the sciences. It's not true for any other discipline. So the students are sitting into school mathematics and they're very happily there, performing very highly. And then they leave this context where they have been successful and join the other context, so the university mathematics. And in this context, they are novices. They don't understand the practices and they don't understand the norms. Often the students talk to us about having found a discipline that they didn't know it was like that people have the same name for the school one, but it's actually really not the same. And in this stage, there is this crisis that happens. If the students manage to overcome this crisis, then they become participants of the practices of university mathematics. And they become successful university mathematics students. The thing which is really interesting about using this framework is that, first of all, it tells us where we need to go and collect data if we want to investigate this passage. We need to go during the liminal stage with students thinking about the before and their experience now. The second thing which is really powerful with respect to this framework is that in the theory of rites of passage, the crisis is necessary. If the student doesn't undergo the crisis, the student doesn't join the second stage. And this is really interesting for those of us who have been thinking about university mathematics and how to facilitate the entrance. And there has been for a while an idea that if it only made university mathematics a little bit more like school mathematics, everything would be fine. This framework says, no, things will not be fine because the students will not join the passage. The second theoretical framework that we have, so this crisis is inherent in the passage, indicates us that we need to look for a before and after, and instead of avoiding this crisis, we need to understand this crisis and see where the crisis is, and then we can know how to scaffold the students. The second framework we have used is the framework of the TMA framework, the three-dimensional model of attitudes towards mathematics. This framework describes the way in which the students position themselves with respect to the mathematics, and this is what guided the design of our research tool. This framework consists in emotional disposition, perceived competence, and vision of mathematics. I'm not going to go very much into the details of how these frameworks work, but in the paper by Di Martino and Zahn, they have really interesting operationalization of this framework, which is what we used in the design of our tool. So, summary. We decided to carry out a comparative, I don't really want to call it a comparative study because I don't think that's a word I want to use, but we decided to repeat the same study in 3 countries and using the same research tools. And we posed these 2 research questions. So the first one is, does the context in which the transition happens impact on the transition? So what is the role of the educational context? My students work in Italy. Is that different? And can the 4 perspective, epistemological, cognitive, affective, and sociocultural, shaping the crisis, are they linked to, can this perspective be investigated holistically? So I don't just want to know the students have a lot of problems using quantifiers. Obviously that's interesting and is important to know, but that's not all the story. Okay, so what did we do? So we designed a questionnaire where we tried to replicate in sections the parts of the TMA model. So we asked students about emotional disposition, views of mathematics, and perceived competences. And we encouraged the students in the question to think about the before and an after. So how was the situation in school and how is the situation now? The analysis of the questionnaire is interesting. I probably will not stop too much about this, but because we wanted to have something that would allow us to make a comparison, we operated with a very, very strict coding of the data. The data is mostly qualitative, okay? That would allow us to use the same code system across the 3 sites of data collection. So then we could do something with this. So the questionnaire is some biographical information, something about the university, something about studying mathematics, and something for a comparison. And here, actually, in another talk, it would be really interesting to talk about the issues connected to translation. I was, because the questionnaire was initially designed and written in Italian, and we translated it into English and into French. And yeah, AI will just not do it. That's the only thing I can say. I had a conversation with a colleague of mine in Finland, because we are doing something else together, where she was explaining to me that in Finnish, the word effective doesn't really exist. So I was like, whoa, okay, excellent. But that's for another talk. So we had this questionnaire, and this is our sample. So at the University of Loughborough, we collected 44 questionnaires, and the qualification of the students that filled in the questionnaires were very uniform. 42 students had A levels, and 2 students had some other qualification. And this is already interesting, right? So if you look at what happened in France and what happens in Italy, the qualifications are all over the place. We explain in the end of the paper something about the educational systems. In Italy, you can access mathematics as long as you have finished 5 years of high school. Anything, like with any marks, anything. So already this is telling me that I'm not looking at student bodies whose experiences are really comparable, right? So this is the analysis. I'm not going to spend a lot of time on this because otherwise I run out of time. But what I want to stress here is that the aim of this reflective thematic analysis was to arrive at a bunch of codes that would be shared across the 3 sets of data. Because in that case, then we could see whether codes were repeated and what were the codes distribution. So in certain cases, we try to understand through statistical means, so by doing statistical significance, whether what we were saying in the qualitative data was something that in a larger in the larger data was something that we could see. And this is why this took so long, because the coders then had really to have near to 100% agreement on the coding that they were doing on the qualitative data. So today here, I'm only going to report a little bit of the findings, because otherwise it's too long. But it's just to give you an example to the things that we found and the differences that we found across the 3 data sets. So we collected basically the profile of the students at entry. I'll talk about the motivation for choice, and I will try to talk a little bit about the perceived differences between school and university in kind of a more holistic way. Okay, let's go. This is the profile entry school. We asked the students to think about their experience in school, how they related to mathematics. I'm not going to say the whole text of the questionnaire. You can see it as the back of my paper. But this is something that we really expected, right? So a student is doing mathematics, so they're very positive about doing mathematics. I would be worried if this wouldn't be the case, right? The vision of mathematics at school is dominated by process, right? So they see mathematics as a procedural discipline. So they are given something to do and they put into some sort of machine algorithm calculation and they do it. And they also think of themselves very, very competent in mathematics. And again, this is because if you access mathematics, in the UK at least, it means that you have had really high A levels. In Italy and in Switzerland, it's slightly different. In fact, you can see that the competencies are not quite tying in. So if you like, I take this as the representation of my TMA framework at the school stage. What are the points to notice? The pictures seem to be the same, right? But actually, when you dig deeper, it's not quite the same. The qualitative analysis helped us understanding the differences. And one of the differences, which I'm going to talk about today, is the reason for joining mathematics. And we know that this is important because this has got to do with motivation. And we know the motivation impacts on attainment and all this kind of stuff. So the thematic analysis told that the career prospects, so extrinsic motivation, is the largest motivation in UK students. This is a typical quote. I thought that it would allow me to keep lots of career options open for the future, as I knew that I wanted to do something maths related. Interestingly, amongst the Italian students, this was not the case. So the Italian students talked to us about passion. I didn't want to drop a subject I felt passionate about. Even when they talk about jobs, the jobs they talk about is always related to teaching. So they say things like, I'm doing mathematics because I want to become a mathematics teacher because I'm really liking the job, and so on. The Swiss students are a little bit in the middle, so we found both motivations. So we found some students that told us they were really interested in maths, some of the students that told us that were thinking about career choices. Actually, interestingly enough, I'm now currently doing a study with my student at Edinburgh regarding course choices, and these themes are all, so why they chose certain courses and why not a lot of students do pure mathematics courses. And some of these motivations are coming out again. So it's kind of nice to see that there is some relation. So why is this important? So we did the code distribution, and for motivation, we did find that passion was significantly higher in the UK, in the Italian sample than in the other two samples, and from the UK students, it was work-related, like a work outcome. Now, this should not be surprising us, because UK university live on the employability discourse. What do we say, our students? Come and do mathematics because you found a job tomorrow. This is not the case in Italy, and it's not the case in Switzerland. Italian universities are still completely publicly funded, and the employability discourse, of course, exists, because we all need to think about paying bills and buying a house. But it's not that strong, so we shouldn't really be surprised by the fact that for our English students, this external motivation is incredibly strong, whereas for our Italian students it's not. Now, motivation is important because we know that motivation impacts the relation to the subject and impacts attainment. And it's important to see that there are these differences. So this is one. Now, this is the interesting bit. That we gave them the same questions, and we asked them to think about their university. So how are you now? And boom. Emotional disposition, nobody's happy anymore. And when we wrote ambivalent, we meant responses of the time. I'm really frustrated when I cannot do a problem, but then if I manage to do it, I'm really pleased with it. So there were quite a bit of this as well. Now, the kind of the procedural aspect is more or less disappeared. It appears only in vis-a-vis conceptual aspects, and this is really also important. And the other thing which is really interesting is this decline of perceived competences, which also impact on the students' kind of process in their degrees. So already by looking at it like this is quite striking. Now, I want to talk for a moment about emotions. So the change in emotions associated to mathematics are startling. So the students don't feel happy in their situation of students anymore. They don't feel happy with the subject that they've chosen. The interesting and these emotional negative emotions are starting to appear in all the three samples. So I have some example here. So for example, this is by ambivalent, right? So it's hard, there's satisfaction when it's right, or dislike, reluctance to attend lectures, which leads to further dislike or frustration. These are our English students. But the Italian students are also quite interesting. I love this one. So these students, when they were asked, how are you feeling? They said to us, I'm feeling like in quicksand. I don't know what to do. And so we can see that this decline in emotions is common to all the three samples that we had. The vision of mathematics, so the third item in my framework, is also quite different. And what we observe here, we observe an influence of the school curriculum on the students' vision of mathematics. So the Swiss students tell us what we were expecting, so that the mathematics studied at school was mainly composed of application, and there were very little, if any, proofs to do. So this idea of proof is something that is really pervasive in the transition kind of studies in mathematics. Now, in the Italian high school curriculum, there is a little bit more, especially in the secondary science high school, I don't know how to call it. There is a little bit more of formalization of mathematics. So there is some idea of talking about proofs, done better or worse in different schools by different teachers, but is in the curriculum, this idea of formalization and proofs. Not so much in the Swiss curriculum, and we know not at all in the UK one. And this has changed a little bit the way in which students tell us how they have got this impact of this formalization of mathematics. So, in the UK sample, the new nature of mathematics, so this idea of mathematics as a formal system, it dominates their answers. This is all what they talk to us about, is the difficulties, the formalization, the language, the quantifiers, all this kind of stuff. So this student, for example, it says that it's much more centered on proof, and this is always, always, always. Maths at uni is much more proof-based. And again, we know that the A-level mathematics curriculum doesn't cover this idea at all. And the moment the students come in, we start talking to them about all these weird and wonderful things without any warning, mostly. So there were other differences, noticeably, and I'm not going to talk about this in the talk today because otherwise I'm never going to finish. We found differences in the student positioning towards the mathematics. So some students told us that they felt that was the mathematics that had become more difficult, while other students felt that was their proficiency that had declined. And this impacts on the way in which the students approaches the subject, right? So if I feel that my proficiency, for some reason which they couldn't explain, has declined, I would act in different ways where I think that is external to me. Maybe I'm just facing something more difficult. So what did I want to say with this study? I've given you a little bit of a flavor of what we did and what we found. But I think that the conclusions that we wanted to draw are a little bit kind of more general. So the first thing we want to say is that it is possible to look at the transition from a holistic viewpoint. So not just from the conceptual difficulties, which are very important, but also adding up other difficulties. I also want to point out that some of the sociocultural differences which have been studied, we had a whole section in the paper about teaching, for example, which I haven't reported here, are germane to mathematics because it's mathematics classes that look in a certain way, not classes or other disciplines. A-level mathematics classes are typically very small. They are not in all schools. The students are followed much better than much larger A-level classes. So these items are related to mathematics in this way, for example. The other thing that we want to say is that it is possible to chase differences. So our students told us different things, and they suffered from slightly different crises. Now, from the point of view of me, who's teaching my students, in fact, I am designing an Introduction to University Mathematics course in my institution that will start next year. It's important to me to know what is the UK students' position in relation to what may be the position from some other place. The thing that we didn't want to do, we don't want to pretend that this is the be-all and end-all of these differences. The idea was to try and tease out the importance of the context. And I've asked myself, we studied the University of Pisa and Loughborough, because I used to work at Loughborough University when we did the study. I only recently moved to Edinburgh. And I think we went to EPFL at the end. I don't remember the Swiss side, just because for convenience, like when we do all studies, we kind of reach out to the participants we have. But I've asked myself, well, what would have happened if instead of having Loughborough University, we had Oxford? Or instead of having Pisa University, which is in that kind of category of universities in Italy. It's one of the most famous universities in Italy. We had another university. So the idea here, and I want to go back to what I was saying before, that whenever we look at educational results from educational research, I think we should be able to understand the context in which the results were obtained and try to see what happens in our context. And this is something that I encourage my colleagues to do all the time who teach mathematics in the mathematics department. Because there are differences, and they are important. And they are important because it can guide the design of our teaching. So, what do I want to say at the end? At the end, so my takeout from this study was, above all this, and this is something I negotiate with people all the time, we must not make the mathematics easier. This is not going to work. The students are going to head against what we think in university mathematics is. We just need to be aware of what they need. So I'm not in favor of throwing them in a classroom like it was 1988 and teach them analysis. We need to know what they need, but different study bodies will need different things. And we need to find out what these are. And that's me, done. Where did we take the work? So we were so excited about this study that we decided to publish to publish a special issue in Educational Studies in Mathematics. The special issue is interesting because instead of going for an open call as everybody does, which I think is a really great thing to do, we wanted to, we invited papers with the idea of having a geographical spread. And so we have papers from Hong Kong, from New Zealand, from, I remember, Israel, from, well, our paper is from 3 countries and so on. We only partially succeeded in this because life gets in the way. We were talking to a team of colleagues in Africa that just dropped out because they had other problems, like, for example, civil wars. So it's really hard, but we tried to make a little bit this special issue about the variation and the impact of the educational context in various transitional studies. So you can go and check it out. And thank you for having me.